So, how can we manage effective refiling and understand whether the available routing can be impacted by other hotspots and delays? This is still a manual process, effort-consuming.
How could we manage sudden changes in traffic demand and have the possibility to warn the AIRBUS about the risk of new congestion?
What about the way we deal with those flights that are critical for us if they are delayed?
How to know which flights are critical for the different airlines affected or impacted by flow management measures?
How do we reduce the coordination effort between airspace users and the e-help desk? And how do we reduce the impact of an airspace user request after the slot has been issued? Moreover, since it's then close to its departure time.
How to consider business aviation specificity? For example, our need for flexibility or the ability to fly above congested area thanks to aircraft performances. And how to deal with the diversity in business aviation operators. It should also allow a flight preparation customized to each business aviation operator needs. During negotiation process, the capacity to fly above congested area will thus benefit to all stakeholders.
The aim of this key research and development activity is to reduce the impact of ATM planning on airspace user cost of operations. In order to meet the objectives, 3 concepts were validated during the project. First, airspace users would proactively provide the flight delay criticality or P-FDCI information to NM and ANSPs. This concept of P-FDCI allows airlines to tag certain flights as critical to their operation, allowing NM and local flow managers to take better decisions to reduce the cost of ATFCM delays. Second, FMPs would declare a protection hotspot to warn airspace users that a certain sector is becoming congested. This improves trajectory planning and increases network stability by preventing a significant proportion of ineffective refilings to avoid ATFCM delays. And finally, the flow management information, including protection hotspots, would be integrated into the airspace user flight planning systems. This improves user situational awareness and workflow for the optimization of the planned trajectory. This is also a key step toward the automation of collaborative trajectory planning processes.
This solution performed 4 exercises between 2020 and 2022. To those exercises, we had 7 airlines, 2 ANSPs, and Eurocontrol network manager participating. To set up the platform, we had 6 partners developing their prototype. All those prototypes were connected via swim services, B2B services provided by the network manager. Eurocontrol led the last exercise. These validation exercises were run with the real-time traffic in shadow mode with actual flights and the situations, ATFCM situations, and with all the participants present using all the prototypes that we had developed.
We prototyped a new functionality into our in-flight planning system. Using enhanced integration with Eurocontrol's network manager, the new functionality ingests flow management constraints and automatically proposes new routes, aimed at avoiding regulations and hotspots. This helps to minimize delays while optimizing cost.
We enhanced our Suite for Airlines product, helping airlines minimize network disruptions. Airline users were able to submit critical flight designations proactively and reactively, as well as view a situation display and alerts for data newly available from Eurocontrol's Network Manager demand capacity balancing functions.
It was a pleasure for Thales to contribute to Solution 38 exercise. Collaboration with our partners was very fruitful. In particular, Italian FMPs have tested our prototype to validate concept of critical flights or proactive use of airspace. And this concept paved the way for closer collaboration between airlines, network manager and air traffic control for a greener use of airspace.
Both concepts, protection hotspot and proactive FDCI, are strongly supported by all the stakeholders involved, and we are fully confident that they can be implemented at very short term.
Thanks to better information exchange with NM and FMPs, we expect to better optimize our flight trajectories and reduce dispatcher workload.
We are confident that this concept will improve the coordination process with NM and airspace user and allow us to make better decisions.
Due to the future implementation of the proactive flight delay criticality indicator, the P-FDCIs, we in NMOC expect to reduce the amount of e-help desk calls, as most issues could be solved before SID1. The protection hotspots, we expect to reduce the demand instability thanks to less late flight plan changes in these areas, and optimize the network usage due to better collaboration and sharing of up-to-date data amongst all actors.